Alright, we got her in the mill. I'm gonna put it on low and I just hold it here. Woohoo! So see how fast that's turning compared to that. That's going 5 times faster, which would be 500 RPMs is all, when the spindle itself is going 95. So let's see, next is 1M, which is 175, and then 1H, which is 310. So this will be 1550 RPMs. So this is the max spindle speed of the mill, but I'm still in low gear. And that feels pretty good. It says to let it warm up for, I don't know, 5 minutes or something before using it. Sucker is cruising. So. 4250 at this spindle here. And there's a little bit of pressure on it. But I mean, this is so much better. This will be so much better, even with the lacking rigidity that we lose. This will be so much better, I think, for little tiny end mills. All right, high speed. So this is 7,500 RPMs. Awesome. And we're gonna check runout on this spindle. So I stuck this on just in case I dropped it or something. Didn't want it to mess up the threads. All right, so let's do a little runout testaroo. Just about on 0. Wow, that's not even moving. Let me see if I can zoom you in on it. Shouldn't have messed with it. All right, let's see. Let's move. Okay. So this is a 1/2 thousandths indicator. It's within a 1/2 thousandths on the runout. And that's, oh, this is a 1/10 indicator. Holy cow. So this is 1/1000ths of an inch with me pulling on it. And those are tenths. And it's just barely moving. I'd say that's pretty good. All right, so I'm gonna have to pop this thing off and mill this out just a tiny bit more. Cause it's not over quite enough, but we have a nice machine surface for it to rest against. And then I think it'll work perfect once I get that milled out just a little bit. All right, so what I was saying was we need to machine. So this is right in the middle and we hit right there, and I need it to bottom out. I need it to come over just a tiny bit further. I think this will be fine since I don't ever use the depth stop, so we'll just cut just a little bit out of there, and we'll call it good. Then we can at least try it out, make sure everything works. All right, I've got a Niagara 3/4 inch roughing cutter. Actually, I might not use this one. I wanted a rounded corner. This looks like it is sharp corner. It's kind of hard to tell, but I think that's a sharp square radius. And I think I want more of a radius. Let me see if I have a different one. All right, I have a 5/8. And this one is a Hanita, made in Israel. All right, I'll bring it back once I get it. All right, so this is what I was talking about, why I like my quill, is I can just bring it down. Instead of messing with the Z jog and trying to get the paper in there, I can just bring it down until it touches right there and call it good. So there's my 0. Beautiful. I don't know, probably, I won't even cut all that out. I'm just gonna go kind of close to the line. And then I'll probably just clean this whole surface up in here. Just cause. Wonder what speed, probably 1500. That'll be good. So yeah, we're just barely touching right there. Let's see if I even touch this back edge. Doesn't feel like it. All right, here's how she turned out. I think it looks pretty good. Got the edges cleaned up, and we've got our nice round area for our for the thingy to go. All right, so that sucked all the way up into the spindle, and it looks like I actually need to extend it. So it's supposed to be about right there when it's pushed all the way down. So to do that, you extend it. All right, I think we got it set. So I've got a nice even gap between, well, you guys can't really see that. Huh? So you'll kind of want that thingy there to be in the middle. And that's what will allow you, if you had a CNC machine that had auto tool changer, it would automatically set this, see this notch, that's where this groove goes up into. That way when you release the tool, this thing comes up and it locks in. That way this thing can't go flying out, and it keeps it in the exact orientation it needs to be for the next time it pulls that tool out of the tool changer. I'll do what I did with the knife blade for these grooves. I'll just grab a scrap piece of steel and we'll just run this program, not all of it, just that one, and we'll see how it does. All right, here's our wrench. It was a 19 and now it's a 0.905 thousandths inch, which is I think 22.9 millimeters or something. I don't know. Yeah, we got our little 3mm ball end mill in there. And we're just gonna crank her down. Let's see. Not sure how tight we should be going. Tighter than that, I guess. Oh, there we go. Hard stop. Oh. What? This collet did seem a little bit oversized. And yeah, look. Alright, so we just got it warming up. I got a 3mm ball end mill that had a 6mm shank, which is almost a 1/4 inch. And I'm pretty sure that collet is a 1/4 inch. It's still, they don't feel as nice as like an R8 collet when they're clamping down. Or not an R8, ER20, ER32, whatever, ER collet. They don't have like a positive stop. They just kind of keep tightening and tightening and tightening, and you feel like you're over tightening it. So I just tightened it down and kind of stopped where I felt like it was in a good place. Now we just got to warm it up, and I'm gonna open up the program and we'll see how it does. I'll bring you back once it's ready. Should be good now. little bit of oil on there. Oil doesn't even stick to it. That's crazy. So we're not really making much of a cut yet. It's just barely touching. I think it's just pushing the tool up in there. I must not have the collet tight enough. That's gotta be it, otherwise this would be taking a 50,000 cut. And it's not. So that's, I don't know, man, these collets, they don't seem like they're very good at what they're supposed to do. They just don't have that like positive lock. So I don't know. Like it's a good fit on the end mill, you know? Like it's a nice tight fit. It's just, it's not freaking freakity frackin'. Piece of crappin'. I wouldn't want to risk tightening it any more than I had. It was tight. I don't know if anybody knows what kind of collets these are. Let me know. They're like kind of like what you would see in like a Dremel, where it's got like the dual collet crap, you know. It's kind of stuck in there now. All right, so this, I mean, it's about as close fitting as you could possibly want it. So look at this. So not in it yet. You can see it actually expand a little bit over it. I mean, I don't know how much tighter, how much of a different fit you would want. I mean, that's freaking perfect. And then we've got this one. This might be kind of the problem. Maybe it's just not letting it cinch down. I don't know. I was trying to line up the slits with each other so that all the slits go together. But like it's a tight fit from the big collet to the little collet to the end mill. Everything is nice and tight. If anybody knows what kind of collet these are. So this main collet here is 1 inch, 92 thousandths, 27 3/4 millimeters. At the skinny end, it is about 52 thousandths, a little over 13 millimeters. The fat end, 60 thousandths and about 15.5 millimeters. And then this, it's like step down here to go inside of the nut. And that is about 1/2 inch or 12 3/4 millimeters. Overall length 1.093, 27.84. And I mean, there's not a whole lot to it. I'm just kind of confused why it's not holding the tool better. All right, so I have a 1/4 inch ball end mill with a 1/4 inch shank, and I jammed it in there. It seemed awfully tight, but so here's what I'm thinking. Let me set this down here. So this is tapered all the way down. The spindle is the same way. So it has to clamp this part here that doesn't have any flex, anywhere for it to flex. So you can see it's kind of been rubbing on this very top section because the entire thing is tapered, and so is the spindle head. So I'm thinking either, I mean, it could be that maybe these collets are just bent in from being used with too small of end mills, or it could be, I mean, I can't imagine it would have made it out of the factory with that kind of design flaw, but you can see it's definitely, that's where most of the rubbing is. So I don't know, I'm going to try this 1/4 inch 4 flute end mill, and yeah, we'll see if that gets any tighter. So this was a 6mm shank. This is a 1/4 inch shank, which is only a 1/2 millimeter bigger. But maybe that's enough to make it work. Maybe the taper is just, maybe it just doesn't work unless it's the exact size shank that it needs, which I'm kind of used to, like ER collets and R8 collets, which they have quite a bit of wiggle room. Not a lot, but they definitely have wiggle room. Maybe these just don't. I don't know. So we're gonna give this a whirl, see if it does any better. Yeah, so that did feel better tightening. That felt a lot more, not a lot more, but quite a bit better. Like it had more of a positive stop on it. So let's see if. Oh yeah, beautiful. So that must be it. All right, let's see how she does this time. Oh shoot! Hold on. Set the 0, huh? I was kind of plunging a little bit. I don't know. Yeah, it doesn't like that at all. Could it be too fast? Let's try the next slower setting. That's about a 60 thousandths depth of cut, so it is pretty heavy. I wanted to go a little heavier than I was before, but we're getting a lot of chatter. See what it looks like. It looks like a decent finish, it just doesn't sound good. Let's go one slower. So this should be 2200. Alright, so it seems to be doing quite a bit better. I was getting a lot of chatter, I had it at full speed, and I slowed it down to, right now this is going 2250 RPMs. Because this is a 1/4 inch end mill, it's a little bigger than 3mm. I'm getting a little bit of chatter, it sounds like, but I'm at a 50,000th depth of cut. I got more chatter at full speed, so I just slowed it down. And it seems to be doing fine. I think we're at about, I want to say this is like 18 inches per minute. That's got to be 20 inches per minute. I think that's what I set it to. It really is something to blow the chips out the way. Probably doesn't help. Inches per minute. Way faster than I would have been able to do at 1500 RPMs. I bet it'll do a lot better in like aluminum, because this is kind kind of hard still with a 4-flute 1/4" end mill. Let's take it up to about 30 inches per minute right now. There's about 30. Which is faster than I could do anything on this mill. I couldn't do any end mill in any material this fast. And we'll stop it there. And see what it looks like. Let's see what she looks like, huh? Oh man, that, I wonder if I had my Z height off at the beginning. That looks pretty deep right there. No? About 56 thousandths at the deepest. I think because it was taking a full width of cut. The first few passes. Let's see, get you in a little closer. But it's a good, looks like a good finish. See, there's the chatter. So that was a full width of cut right there on that edge. And that edge, all the edges. Once it was out here, it was no longer a full depth of cut, and this is nice and smooth. Obviously, you can see the steps because it's a ball end mill, but yeah, that's cool. I think it'll work really well in aluminum. But yeah, if anybody knows what kind of collet these are. They're similar in size to an ER16, but the taper, I believe, is different. I only have ER20 and ER32, but I think they all use the same taper. And these have less of a taper, so they're not as steep. But I'm kind of thinking they might be custom for this particular big Daishowa whatever brand. And yeah, my dilemma is that these collets just don't have any wiggle room. I think you have to use the exact shank that the collet is, unlike an ER style collet where you can do like a 6 to 7 millimeter range, which would allow you to use a 6 millimeter, a 1/4 inch, or a 7 millimeter. And same with like R8 and even Morse taper. They all have some wiggle room, but I don't think these collets here have any wiggle room. So, I mean, I'm glad it at least worked. So down here, I was going a little slower, but it was a little bit deeper cut. But I had the spindle RPMs up higher, and it does look, you can't really see it on the camera, but it does look like I got a smoother finish. With the higher RPMs, but I was getting way more chatter during the full depth of cut, or full width of cut. So I think, yeah, I don't know. I think on like the finishing pass, I'll do a smaller depth of cut, obviously, and I'll take the RPM up higher, because it's definitely smoother on these first few passes. And then it's a little bit rougher up here when I sped it up to, what did I say, 30 or 35 inches per minute. So we started around 18 to 20 to 30 to 35. But yeah, I mean, I'm happy with that. I think it looks good. It's as good as it was at 1500 RPMs with a 3 millimeter ball end mill. So if I could get a 1/4 inch shank with a 3/16 ball end mill, I think we'll be golden. I think we'll be able to get a much better finish and be able to do it a lot faster, because when I was cutting them at 1500 RPMs, the max spindle for this mill, I was going like 4, maybe 5 inches per minute. It took forever. And now I can go quite a bit faster and still get a decent finish. So, yep. Let me know if anybody knows what kind of collet those are. That'd be super helpful. I can't find any info online about them, so probably custom, which kind of sucks because I don't think this company makes that style collet. Their new spindle speeders use a different style collet now, so kind of screwed there. I think I chatted with Big, and they were super helpful. They're the ones, they got me whatever instructions they could find on it. But according to him, he thinks this is around the late 80s was when it was made. And yeah, they just don't have much information on them. They're not meant to be user serviceable either, so yeah, kind of a bummer there, but I'm happy with that. So that kind of gives me an idea in the future what kind of RPMs I'm gonna want, because if I could just get the mill RPMs up and not have to use this whole thing, that would obviously be ideal, because it would be a lot more rigid and I'd have more options for end mill sizes. So yeah, that's definitely still in the future for this mill, is to increase the spindle speed by way of, I don't know, a 3-phase motor or a belt and pulley system. Probably 3-phase motors, so I can keep the quill and just do a motor swap. But yep, thanks for watching. Glad I could at least sort of get it figured out instead of leaving y'all hanging and me being stuck with a chunk of metal that I can't get to work. But yep, well, the next video is going to be heat treating the knife blade. I tried to do it while I was anodizing, and it ended up kind of being a disaster. So I have an anodizing video that's all recorded. I just need to edit it. And when I hardened the blade, it warped. So I was kind of messing with it, and I kind of flexed it a little, and it just snapped. So that was stupid. So I've already made a new blade. So I just need to harden it and then temper it, and then the knife will be pretty much done. Oh, I've got the handles right here. So here's the anodized handles. My jar that I was using for the sealant, just water, boiling water, you seal it after you dye it, shattered. So I kind of screwed up. I had to take it inside and boil some more water and then seal it. And I think I lost some of the dye when I did that. So there's it's really not too noticeable, but it's not as good as it could have been. But they still look fine. Plus, it just has a little bit of, I don't know, color variation, I guess. It's hard to see in the camera, but there's a couple little kind of spots, I don't know, somewhere on here. Anyways, yes, stay tuned or subscribe to see the next videos.